Welcome to 8.0 Trigonometry. Um, as you can, if you have been following the pattern of the lessons there, you might have noticed that there is no point O. However, I am trying to cement in your mind that trigonometry is a very important topic, so I'm going to give you an extra lesson just to practice trigonometry. So what's Oh God, I'm sorry. This is chemistry. What's trigonometry? It's the study of triangles. Uh, Specifically, a tri is three. Gon is angles. So three angles. Geometry is the study, right? So the study of three angles. The study of three angles. That's basically what it means. Right? And the study of triangles involves a few things. Um, it involves the relationships of the sides of the triangles and its angles, which is our main focus for this unit really. But there's also the applicability of triangles into other shapes. For example, you could use trigonometry to prove the triangle inequality theorem. Well, that's a triangle. You could use trigonometry for other non-right triangles. You could use trigonometry for hexagons, right? You could use trigonometry for a lot of things. And we're also focusing on analysis of relationships on the Cartesian plane and other spaces, which basically means we're going to analyze their functions. The functions of trigonometric functions, is what they're called, are sine, cosine, tangent, cosecant, secant, and cotangent. But for now, these first three are the most important: sine, cosine, and tangent. Specifically these two, but the tangent is pretty important as well because there's no other way to represent the ratio between the two legs if we don't use tangent. So, example 2. Trigonometry starts with a relationship between sides and angles in a triangle, right? And if you have a few sides and a few angles, you can figure out the rest of the sides and angles. So, the relationship of sides and angles are represented as sine, and angles are represented in this shape right here. It's called a theta in Greek. So, sine of theta, which would normally be written sine of theta, right? Or cosine of theta, or tangent of theta. And sine of theta is opposite over hypotenuse, and cosine of theta is adjacent over hypotenuse. Tangent of theta is opposite over adjacent, right? And this is basically just a graphical representation. Sine is opposite over hypotenuse. If the reference angle is right here, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? So there's this mnemonic that normally is taught, and the mnemonic that is taught is so ka to toa, right? That's the mnemonic that's normally taught, right? It's one of like the most famous mnemonics of one of the most famous abbreviations, you could also say, of math. It's called SOHCAHTOA, and SOHCAHTOA is basically you could just kind of carry out all of the trigonometric ratios just by saying SOHCAHTOA, because so is sine, is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. See? SOHCAHTOA, right? It works, and I'm just gonna use it because it works among high school students. Anyways, we have ourselves our example. So none of these are going to actually, maybe some of them are going to be from the book, but none of these are really going to be from the book because we need to brush up on our trigonometric basics. So find sine, cosine, tangent for theta. I don't expect a real answer. You could try if you want to. Try right now. but today we're just going to we're going to find just like sine of theta is equal to whatever, right? So that's your right angle right there, and that's your theta. So this is it sine, cosine, or is it tangent? Well, what do we have? We have our adjacent and we have our hypotenuse. So we have cosine, this is cosine, 9 over 14. Boom, 9 over 14. But it says find sine, cosine, and theta. Find sine, cosine, and tangent, not or tangent. So we actually got to find this other side. The other side we could just do by Pythagorean theorem. That's 14 squared minus 9 squared equals, I think c squared. Yeah, c squared. And then that is 196.81, 115 equals c squared. So c is equal to square root of 115. Let's just do square root of 115 on this side. That's 81, will give you 196. So then sine of theta will be equal to square root of 115 over 14. Sorry, this is how I was supposed to write it down. I was not supposed to write it down like this. Cosine of theta is 9 over 14. And tan of theta is, well, how much is tan of theta? Tan of theta is opposite over adjacent. Opposite the theta over adjacent. So square root of 115 over 9. Next, we have 4 and 2. So we got to figure out the hypotenuse. The hypotenuse is, well, 4 squared plus 2 squared is 20. And square root of 20 is the square root of 20, or 2 to the square root of 5. That would make you a little cooler because you can simplify it later, right? So sine of theta is just opposite over hypotenuse, which is square root of 5, which is 2 over 2 square root of 5. We're old enough now. We don't need to rationalize the denominator anymore. But if you want to rationalize the denominator, here you go. Square root of 5 over 5. Cosine of theta is 4 over 2 square root of 5, which is 2 over square root of 5, which if you guys want to rationalize, it's like this. And tan theta is, it's actually pretty simple. It's just opposite over adjacent, so 2 over 4, which is 1/2. This is a pretty nice one, see? They don't always have to be ugly. So number 4. So the main trigonometric functions also has reciprocals, and they're called secant, cosecant, cotangent. So cosecant is 1 over sine, secant is 1 over cosine. It's a little confusing, right? So sine, cosine, secant, cosecant, right? You would think that the cos would meet up with the cos and the s would meet up with the s. No, it doesn't, right? Sine meets up with cosecant. So sine theta multiplied by cosecant of theta is equal to 1. And secant of theta multiplied by cosine of theta is equal to 1. Because secant's just 1 over cosine, so cosine multiplied by cosine, that's 1, right? We're gonna deduce many more identities like this later, but and cotangent is obviously just 1 over the tangent, right? So find all 6 trigonometric functions for this triangle, right? We have our 2 triangles, 2 and 2, square root of 2. So let's just do the Pythagorean theorem. That's 4 plus 8, and square root of 4 plus 8 is 2 square root of 3. 2 square root of 3. Right, you can do the Pythagorean theorem by yourself. I'm not going to do it, not to waste time. Right, so sine of theta, cosine theta, tan of theta, cosecant of theta, secant of theta, and cotangent of theta. Right, this is how you write cotangent, is COT. So sine of theta is opposite over hypotenuse, so opposite over hypotenuse is square root of 2 over square root of 3, or rationalize square root of 6 over 3. Cosine of theta is adjacent over hypotenuse, which is just 1 over square root of 3, or square root of 3 over 3. Tangent of theta is equal to, let me move these out so it isn't extremely messy. Oh my god, these are grouped. God damn it. Let's just erase it. Okay. So tangent of theta is equal to opposite over adjacent, which is 2 square root 2 over 2. So 2 square root 2 over 2, which is just square root 2. Right? And then since we have all of these now, we can just say CSC cosecant of theta is equal to 3 over square root 6. Or if you want to rationalize, it's 3 square root 6 over, no, it's square root 6 over 2. Right, 3 square root 6 over 6, which is equal to square root 6 over 2. Cosine, secant theta is equal to 3 over square root 3, which is just square root 3. And cotangent of theta is equal to 1 over square root 2, which is square root 2 over 2. And that's it. Next question. Using a calculator. This time we have to use a calculator, right? We have to find the values of all our angles and sides. Well, that's 20. So we have, actually, yeah, that's 20. So that's 70. That's simple enough, right? So now we have, we can use any angle we want. We just need to have this 6. So let's use sine, right? So a sine of 70, right? So because remember theta represents an angle, sine of 70. We're going to tell you how to convert this into radians later, which you will need for your class. But now we're just going to work with degrees. Sine of 70, I have my phone next to me, is equal to 6 over hypotenuse, right? 6 over hypotenuse. So you can switch the h and the 6 together to get, just by basic algebraic manipulation, you can do h equals 6 over sine of 70. And I'm calculating sine of 70 right now on my phone. 70 sine, no, degrees, 70 sine. Oh no, 70 sine. And 6 divided by 70 sine is 6.385. 6.385 is 70 sine. And what is 20? So this is like 6.385. And in order to figure out this, we just use cosine, right? So cosine of 70 is equal to, now we have a, like, let's say b over h, right? And we already know our h is about 6.385, right? So we can just plug that in, and then now we have 6.385 multiplied by cosine of 70 is equal to b. And what's cosine of 70? It's a pretty small number. Yeah, it's a pretty small number. This is totally bad it's a totally bad triangle. It's not to scale at all. But it's 2.1, so 2.1383. So b is equal to 2.138, and that's it. So, in order, if you want to get the angles from the given sides, you have to use the inverse of each function. Well, I forgot to make this a right angle triangle. It has to be right angle triangle, or else it will not work against trigonometry, right? We'll tell you cases that it will work for, but in this case it doesn't work. So find angles and sides. We have 4, 7. So let's say our theta is right here, theta, right? So we have opposite over adjacent. So tan theta is equal to opposite over adjacent, 4 over 7. So every single time we want to every single time we solve an equation, we're actually multiplying by the inverse of everything. So in order to find out theta, we actually have to take the inverse tangent of 4 over 7. So if you have a calculator, you can do it right now. It is inverse tan of 4 over 7. And you might get something in the form of radians, right? If you get it in the form of radians, it's totally fine. I'll tell you how to convert it in like the next few episodes. But this tells me that it's 10.851 degrees. So this is 10.851 degrees, which will make this, wait, it's 10.58. That's really small. No. Okay, yeah, cause I did it wrong. There you go. Inverse tan of 4 over 7. Okay, now it's 29.744 degrees. 29.744 degrees. That seems a little bit more plausible, right? Since we have this now, we can figure out the other angle just by subtracting it from 90. This will give us 60.256 degrees. And we can figure out this by Pythagorean theorem. So 4 squared plus 7 squared is 65. So this is the square root of 65. And that's nearly it. We got one more question. So our final question is, to measure the width of a river, you plan on a stake on one side of the river, and then directly across a boulder. You then walk 100 meters to the right and measure a 78 degree angle between the stake and the boulder, right? What's the width W of the boulder? So simple, right? We have our 79 right here, we have our W, and we have our 0, right? What do we have? We have the opposite, and we have the adjacent. So tan 79 is equal to opposite over adjacent, which is 100 tan 79 is equal to opposite. So we will calculate that. That is 100 times tan of 70. Oh god, sorry. 100 times tan of 70. 100 times tan of 79 is 514. W is equal to 514 meters. And that's going to be it for today's episode. That was pretty long. But now you know the basics of trigonometry, and we are ready to tackle at a more advanced level of trigonometry in the next few episodes of this course. This is the last really big unit we kind of have. After that, we have statistics, maybe a little bit of geometry later, but that's the last really big unit we have. So I'll see you next time.